probably chew up whatever time we have teaching this. This is Algebra 1, Lesson 18, Combining Like Terms. And I think we've talked about this. I think you guys probably already know this. Are you guys familiar with combining like terms? Okay, the biggest deal here is that the coefficient doesn't matter, but the variable and its exponents do matter. You guys aren't out of here till 9:48, so we've got about 12 minutes. So I'm going to read this quickly. I'm going to try to explain it quickly. Two or more terms that have the same variable or variables raised to the same power are like terms. Just because I have 3x squared plus 3x to the third, I can't combine those. They don't have the same exponent, okay? If they're different variables with the same exponent, it doesn't matter, okay? The things that I can combine in what we see down here are 3x to the fourth and 5x to the fourth. Okay, I can't combine 5y to the fourth plus anything. Okay, so terms with different variables or terms with the same variable or variables raised to different powers are not like. They're unlike terms. Because the variable x has the same power, 3x to the fourth and 5x to the fourth are like terms. So that's going to be 8x to the fourth. I combined them. If that had been negative 5x to the fourth, I would take 3x to the fourth minus 5x to the fourth. I would have gotten negative 2x to the fourth. Does this make sense? All right, these are rules for adding and subtracting. It's different if we're multiplying because we can multiply. We don't need like terms to multiply. Okay? The coefficient is not used to establish whether terms are like or unlike. Okay? The way I think about it is it's apples and oranges, right? I can add 2 apples plus 3 apples, and I can say that I have 5 apples. Okay? Or if I have, baskets of things, but I can't add apples and oranges. Okay? All right, that's it for that. So let me see if I can pull up some questions that we can work out before we have to go. Let's see, we are on, lesson 18 here? Okay, let's pull this up. Let's see if we can answer 2 or 3 questions before we have to go. Okay, we want to identify the like terms in this expression. Okay, we've got negative 3y to the fourth, negative 3, positive 4y to the fifth, positive 7y to the fourth, and positive 8y to the seventh. Do we have any like terms? Negative 3y to the fourth and 7y to the fourth. Those are my like terms. That would give me 4y to the fourth, correct? Okay, great. This is why if you go back and watch the video, you want to listen because I'm not writing all this stuff down. Right? Number 2, simplify 2z plus 9 minus z plus 3. What exists in front of a variable where there is no number? 1. So I have 2z plus 9 minus 1z plus 3. All right, what are my like terms? 2z and negative z. Yes, you can combine, a number without a variable. Constants are all like terms. Okay, so 2z minus z is what? 1z or z, and I've got 9 plus 3, which is 12, so I should get cz plus 12. Okay. All right, 3, we got 5t cubed plus 3y minus 2t cubed plus y minus 5t squared. Can anybody identify what is an unlike term from everything else? What's that? Negative 5t squared. Negative 5t squared. All right, so I've got 5t cubed and negative 2t cubed. What is that going to be? 3t cubed. All right, I've got 3y and y. What's that going to be? 4y. So we see D as our answer. Okay, let's come down to something that's going to look a little bit different in the question for number 5. Write an expression for the perimeter of the figure, then simplify that expression. Perimeter is what? All sides added together. So if we're going to write an expression, we'd start off with 3x plus 6y, what? Plus 4x plus 5y. Now let's try to simplify that expression. Right? What are my like terms? Okay. So I got 3 plus 4 is 7. 7 plus 2.5 is 9.5x. I've got 6y and 5y, which is, okay, all right. You'd get the same type of thing. The only thing that we have to remember is because we express the perimeter of the following rectangle in terms of n, is I got to remember that this is n plus 4 over here. This is 3n minus 9 over here, right? If we're going to write an expression, I need to remember that I have 4 sides there when dealing with perimeter. Does that make sense? Okay, do you guys feel good enough to work? And you should work. I don't know why so many people have put things away, because you guys do have about 5 minutes. Okay, so that's not zero time.